I wanted to discuss with you what performance engineering exactly is and what it takes to be a good performance engineer. Hello everyone, this is Bruno and I'm the lead performance engineer at Optimum-G. So first of all, what do we define as performance engineering? This area is responsible for the performance of the car. So we want to make the car perform, being it a single lap or a long stint. So it is interesting to notice that performance engineering is not merely analyzing the data. It is a lot more than that. So at Optimum-G, we like to define performance engineering based on 3 pillars. The first one is experience, which is what most people are using at the track. You know that if you make a change to the entry bar, the car is gonna behave in this new way. But we don't like stopping there. We like to include 2 other pillars, which are vehicle dynamics knowledge, because this helps you understand what is happening with the car and also the changes you make, why you are making them, and why the car is going to behave the way it will. This really helps in more complicated situations. And then the third pillar is going to be a data-driven approach. So we are never guessing what we want to change or guessing what the cause is. We are going to the data, confirm that this is indeed what is going on with the car, and then making decisions based on that. So in order to be a good performance engineer, you need to be knowledgeable and in many different areas. So just to list some of them: data analysis, obviously, but also KPIs and metrics are more systematic way of looking at the data, driving and driving technique, tire performance in many different aspects, aerodynamics, powertrain, collecting driver feedback, understanding setup changes, working with simulation, developing your own tools, knowing how to run the test phase, so testing methodologies and run plan definitions, as well as communication with everyone in the team, including the drivers and the engineers. So the performance engineer needs to put all these different skills together in order to make the car perform. So again, the goal of a performance engineer is not to analyze the data. Our goal is to make the car faster, and then it's on us to define which tools and which skills we are gonna be using to be able to accomplish that goal. So I would like to discuss each of these different skills a little bit further with you. And we could start with data analysis. So first of all, by working with data, it doesn't mean that it necessarily should be only log data. We know that there are so many different sources of data. So it could be coming from log data, but also from driver feedback, also from video, timing, competitor comparison, so analyzing where each of your competitors is gaining, tire pressures, wear measurement, temperature, and so on. So we have so many different sources of data. The first thing that we should be able to do is to select what sources of data we are going to be using in a specific analysis, and as important as this, which sources we are not going to use. So we never need perfect data. The data is never perfect. It just needs to be good enough to become useful. But it is on us to understand when we lack so much accuracy that we should not even be looking at that piece of data, because it's going to lead us into the wrong direction. So this is the first thing that we should think when we think about data. All the data that is available and selecting the right ones. Then now, when speaking about logged data inspection, how we are going to analyze logged data from the car, then there are a big range of skills that are needed in terms of processing this data, visualizing this data, so what plots or what type of visualization and processing you're going to use for each different channel and each different analysis, and what conclusions you can draw from it, because we know that the most important is not to be analyzing the data, but it is what kind of conclusions you can come up from this data. So the next skill that is related to data analysis that we should know is driving. We need to understand about driving techniques, understand and be able to visualize and work with our drivers, understand why they are doing what they are doing, and also how their inputs are gonna influence the car balance. So it's not only looking and reacting to what the driver is doing, is understanding that whatever he's doing with the car is gonna change his perception of car balance. And so you need to understand about driving. Using simulators is such a good tool for engineers to better understand this. But not only this, actively studying about driving and understanding what the driver can do is very important. Also related to that is video analysis. We need to be very good at doing video analysis because it is such a powerful tool, not because you have a lot of channels or information, because you don't, but when working with the drivers, it is a powerful tool because the drivers need this visual reference that the data cannot give to them, but the video can. So we always have very productive sessions looking at the video together with our drivers. Even more so than the data, we can collect even more feedback that we didn't get before once we watch the video with our driver. Not only that, we can get references for our driving line, for curb strikes, also analyze their racecraft, race starts, tire warm-up, and get a good understanding of all of this by looking at the video, information that we wouldn't get from logged data. The next topic is, we have been discussing how you should be analyzing the data, but there's so many sensors, there's so many cars that you have literally hundreds of sensors and channels to be looking at. Most of the time you don't have the time to cover many of them, just a few. But a very good strategy in order to be able to compile and to absorb so much data in a small period of time is by using KPIs or metrics. And this is another skill that you should master as a performance engineer. So with KPIs, our goal is to summarize a whole bunch of data into a single value, typically per lap, it could be per corner. But instead of looking at speed traces or any plots versus time or versus distance, we are gonna collapse all of that information into one point per lap. So when you create KPI reports or metric reports, in just 5 minutes, you can basically have an overview in all of the sensors, literally all of the sensors in your car. And then the KPI is gonna indicate to you, okay, it seems like we have an issue with whatever system of the car. The brake hysteresis is higher than it should be. The aero balance is not the way it should be behaving, or during the session it changed for whatever reason. So the KPI is gonna be a very good summary for you to understand what happened during the session and to tell you where you should be looking at the data, at the time or distance plots, to better understand why we saw that shift throughout the session. Not only that, it's very useful also to see progressions during the session, if the car is getting more understeer, more oversteer. So not only looking at what is happening, but trying to identify the causes. You could be looking at metrics of, for example, aero balance, did anything change? Or rear slippage. Why is one driver having so much more understeer over this long stint compared to the other? Is he driving differently? Is he steering or sliding the front axle a lot more? So you can see that with KPIs, we can condense a lot of data and make very efficient analysis. And obviously, you're only gonna start using KPIs once you can automate this process. And this brings us to the next point, which is tool development. A good performance engineer will typically be able to develop its own tools. So if you need to program something, run analysis using Python, MATLAB, or whatever other programming languages that could be useful, or even better, develop tools to run those analyses in an automated way, in a way that you just press play in a script and then it's gonna run this analysis for you. This is gonna be so powerful for you at the track. So just to give an example, generating KPIs report, you need to process a bunch of data, and then you need to create the KPIs, plot the KPIs, export it as a report, and then share this with the whole team. If you don't have a tool for that, it can take you literally hours. If you have your first tool to generate reports, it might take you 1 hour to generate one report for one session or for one event. Once you automate your KPI tools, it can get to the point that it's gonna take you a few minutes, possibly less than 5 minutes, for you to generate the report of the last session, and then you're gonna have a very good summary. In 5 minutes, you're gonna get an entire summary of what happened at the track in this specific session. You can then share this with the team in an automated way, and everyone can check their own systems in the car, aerodynamics, suspension, tires, reliability, to get a good reading of what happened in the session. So again, automation is key, and tool development, it's a very important skill that we should have as performance engineers. The next topic would be setup development, because we discussed so many different areas, and you can put all of them together when you are doing setup development. So with setup development means understanding what is happening with the car from so many different types of data sources. So we are using the data analysis, understand trends, we are using the KPIs, understand if the issues are coming from driving technique, or from the car setup. So we are using the driving skills, and we are also gonna make use of the tools that we developed in order to decide what setup changes we're gonna make. So for example, we could have a tool in which we change the spring and it's give us the new number for lateral load transfer distribution. This makes sure that, as we discussed in the beginning of this video, that we're making data-driven decisions. Not only we're looking at the data to understand what is happening, we are using our tools to quantify the setup changes that we want to make. And in order to be able to make good setup development work, not only you should be data-driven, but you should understand about vehicle dynamics. Because with vehicle dynamics, you can really understand what is going on with the car and deciding what parameter you should be changing. Because, for example, there are so many parameters that overlap that all of them are changing the apex behavior or the corner entry behavior or the exit behavior. But which one should you pick? It should not only be based on driver feedback or driver ideas or experience. It should be an understanding of if it is happening in this part of the corner, in only these sectors of the track, why that is. Is it tire, is it differential, is it entry bar, is it aero balance? And which ones should I be changing in order to fix where I'm having issues and optimize or keep where I'm not having issues. So this is why vehicle dynamics is so important. So as you can see, setup development work is such a fundamental skill for a performance engineer, and we start putting together everything that we discussed so far. But in order to make any setup changes, you need to understand about tires, because the tire is gonna define the whole balance of the car. If you have a very understeering car, but with a very understeering setup, depending how your tire is, your car could even be oversteer. So it's important that you understand all the spectrum of skills required for tire management. Those could be defining cold pressures, determining what hot pressures you want to use, which is gonna be a compromise between performance but also reliability. You don't want to have tire failure, so you cannot run at such low pressures, and you don't want super high pressures not to lose so much grip. Connected to this, you need to understand tire failure. Understanding once you have a tire failure is not only my tire blew up. No, it's what was the cause, what failure did the tire experience in its construction or compound, and based on that information, you're gonna decide what setup change you need to make or driving characteristic you need to change in order to avoid that specific failure. Besides that, you should be looking at tire wear and understanding how to deal with that. Tire temperature reading. Also, performance degradation. Once your tire is losing performance, is it coming because of physical wear? Is it because of thermal degradation? Is it because of overheating? It's very important that the performance engineer can understand the cause of this performance drop, because it is gonna influence what setup change you should make based on that. Okay, so we cover tires. There are many other items that you should know about tires, but it's a very important topic to learn and to apply. Another topic that I could say that is important for performance engineers would be simulation. So it is very important to know not only how to run simulations and possibly how to develop your own simulations, but how you can use these simulations at the track. It is very easy being in the office, running simulations, getting some results, and so on. But how do you convert this simulation environment to being useful in real life at the track? This is very important, requires experience, study, and so on. So what simulations could a performance engineer be using? So many of them. The first obvious one, we could be speaking about lap time simulation. That could be as simple as a point mass or as complex as a full car in transient doing laps around the track with elevation, bumps, and so on. All of them are useful, and they are useful in different ways. And it's up to the engineer, the performance engineer, to understand when you should be using a very simple point mass model and when you should be using a very complicated transient multi-body model. With that, you could be understanding downforce levels, the influence of weight in the lap time, the influence of power, but also even sliding energy, how you should be managing your tires, how you should be managing your fuel. All of that can be studied using lap time simulation. However, a performance engineer should not limit himself to lap time simulation. There are many other simulation types that could be used. For example, sensitivity analysis. How good is it when you go to the track and you already have plots or tables of how much balance you can change versus a given parameter for many different parameters. So basically, this is a sensitivity analysis. You're gonna increase the entry bar stiffness and see how much balance you are changing for different speeds, so that when you are at the track and you understand that your car is understeer or oversteer, you know how much of a change you should make in order to fix the understeer that the driver is communicating to you. So in this case, you can even connect the driver feedback that you should be very good at collecting with simulation. And this brings us to the next point, driver feedback. The way you communicate with the driver is extremely important. We should not assume that the driver is a machine, a robot, and that they are going to transmit all the information we need. No, we need to give them a very streamlined and structured way of providing us with information that is useful. So we need to encourage the driver to give us all the feedback that he can, but it's also on us to understand what is really useful and we're going to be using and what is his opinion but not backed with the data. Simple example, many times the driver is going to see on the dash that he had ideal grip when the pressures were 1.7 bar. So he's going to come into the pits and he could tell us 1.7 is the pressure that I need for a qualifying lap, for example. It could be the case, so we should be welcoming him to provide us with this type of information. But what if it is something else? What if the peak grip was actually not coming because of the pressure, but it was coming because of the temperature? We have that information. So it is on us to define what we are using from the driver feedback and what we are not using. So not only driver feedback and communication is important, but the communication with everyone else in the team is important. How you communicate with the race engineer, how you communicate with the mechanics, how you communicate with the car chief, all of that is very important. Why? You need people to trust us. You need people to trust you, not only to trust you in the setup changes that you are proposing and that you would like to experiment, but people should trust you so that they can give you all the information you need. For example, let's say that someone made a wrong setup change. You need to be open to receiving that information and working from there, working with that information and fixing the issues. If people are not telling you what happened with the tires, a wrong tire pressure set, a wrong setup change, it's going to be very hard for you to understand what is going on with throughout the event. In the same way, the communication with the race engineer is very important so that he can provide you with all the information you need and that he can trust you in your decisions, in your requests for setup changes. And this brings us to another topic, which is testing methodology. You should think of yourself when you go to a test day or to any free practice session as a scientist. You need to have a proper methodology in order to understand your setup. You cannot be misled by, for example, track conditions changing and you assume that it was the setup change you made, or the tires are getting worse. You are wearing a lot of the front tires, and then you are thinking that the setup change you made was actually going in the opposite direction. So for example, let's say that with tire wear, your car is getting very understeer quickly. You need to identify that and work around that, because if you make a setup change that it's supposed to be going on the oversteer direction, but the car balance remain the same, you can understand, okay, actually my change went in the oversteer direction, but I was already seeing from my KPIs that even without this setup change, the car was already going in the understeer direction. So testing methodology, how you organize your runs, when you put a new set, when you do not put a new set, and what are the conclusions you can draw when you don't change a tire or you change the tires is extremely important. And the communication with the race engineer is gonna be very important. So these are just some of the skills that a performance engineer needs. And remember, the most important part, what is the goal of a performance engineer? To make the car perform. So we need to decide which of these skills we are using, and even more than that, how we can connect all these different sources of information and all these different techniques in order to make the car fast. And actually, so we just saw what skills we need and what it takes to be a good performance engineer. And this video series that we are publishing is discussing exactly that. So this covers all the different areas. This specific video covers all the different areas that you should be mastering to be a good performance engineer at the track. And in this series, we're gonna be tackling many of these different aspects and explaining to you with material, with examples, real examples, how everything is working. So how driving techniques work, how data analysis work, how setup changes work, and so on. More than that, we have complete seminars dealing with these subjects. So we have our data-driven performance engineering seminar. This performance engineering seminar is teaching you exactly how to be a great performance engineer by combining not only experience, which is only the first pillar, but with vehicle dynamics knowledge. So all the setup changes that we discussed, we're explaining why they work the way they do, and also a data-driven approach, meaning that all of your decisions are based on data. This seminar is conducted during 3 or 4 days, between 10 to 11 hours per day. Not only we're giving you a lot of content in literally all of these different areas, but we are giving exercises that you are performing with us to make sure that you learn and you can apply these techniques on your own car, together with hundreds of real examples from real data that you can see what is going on at the track and connecting all the theory that we explain with what really happens in reality. So we have 2 versions of this seminar. The regular version, which is 4 days, and we invite both professionals and students. We have 1 extra day explaining setup procedures, workshop measurements, and so on. And we have the pro-only seminar. In this pro-only seminar, we only bring professionals so that we can have a little higher pace, engage in debate, ask everyone to discuss different perspectives, and it's great learning for everyone. I'm sure if you guys enjoy this type of content, you would really enjoy our seminars. You can find the link to the calendar that we're teaching this seminar all around the world in the video description. We also have other seminars focused on vehicle dynamics. You can find all of them on our website, optimumg.com. Thank you for watching this video. I hope you enjoyed the series. If you have any questions or comments, leave them in the comment section, and I'll see you in the next one.